Good morning, everyone. My name is Samyak, and today I'm going to present my project that is quadcopter drone design. So let's delve into this. So first of all, this was our supposed project timeline. As you can see, our first task was the theoretical study of quadcopter. Then accordingly, we had to select the components and then their assembly. And once we are done with the assembly, we had to integrate the ESCs, the BLDC motors, the transmitter receivers with the Arduino Uno. Then we had to simulate the flight controller system using again integrating by MP950. Once we are done with the integration, we had to tune our PID control system. And once we are done with the PID control system, we can replace our receiver transmitter with the Wi-Fi module. And last, we can test our drone. So now let's discuss the fundamental elements of our drone. As you can see, the components. First, we had the frame, which serves as the skeleton of our drone. The frames can vary in shape, size, and material composition, depending on the purpose and payload capacity of the drone. They're typically made of lightweight yet durable materials like carbon fiber or aluminum, basically allowing increased maneuverability and flight efficiency. Next, as you can see, there's an ESC. The one we used is an Emax 7K 20 ampere ESC. Now, then along with that, you can see BLDC motors and propellers. Then for the power source, we used 3000 mAh LiPo battery. And as you can see, along with that is a plane of the drone that is Ampere 9250 and Arduino Uno, which we'll talk about later in depth. So after assembling the components, our task is to control the BLDC motors using Arduino. Since the BLDC motor can't be directly controlled using Arduino, so we need a component that is known as electronic speed controllers. And the electronic speed controller, what it actually does is it basically translates the signals from the motors, from the flight controllers, into specific commands for the motors, which basically allows them to adjust the rotation speeds and direction. Now coming to the integration of these components with the Arduino, as you can see in the schematics, the two power terminals of the ESCs are connected to the LiPo battery, the plus terminal with plus and the minus terminal with minus, and the three output terminal of the ESC is connected to the PLDC motor, and the two input terminal, one of the input terminal is connected to the ground pin of the Arduino, and the other pin is connected to any of the digital pin of Arduino, which we can easily play with in our Arduino code. So this will ensure that we can easily control the RPLDC motor using Arduino. Once we are done with this, our next task is to make the flight controller basically. So before going toward the flight control, let's first see what is MP950, because MP950 is a very important component of our flight controller. So what is MP950? It's basically a very popular and a versatile motion tracking device, which is equipped with a 9-axis sensor. It helps us with a lot of data because it consists of a 3-axis accelerometer, 3-axis gyroscope, 3-axis magnetometer, and it established communication with the Arduino Uno microcontroller utilizing the I2C protocol. It has a default address of 0x68. Using that address, using that address and serial data communication, we can easily, you know, get the data from MP950 to the Arduino. Now, coming to the flight controller, the only difference between the flight controller and controlling motors using Arduino is that in this part we are also integrating the MP950, which is giving us a lot of data of various stuffs like the location, the acceleration, the magnetic field strength, etc. So, as you can see in the schematics, let's first see how to integrate it. The VCC and the GND pins, the ground and the VCC pins of MP950 are connected to the 5-volt and ground pin of Arduino, and the serial clock and serial data pin are connected to the A14 and A15 pins of the Arduino. for serial data communication to get the data of 9 axis. And the rest of the connections are the same as we saw earlier. Now, what, how exactly the flight controller controls the flight? First, we saw that this is how, as you can see in the schematics, this is how the sensor is integrated. Next, the Arduino retrieves the sensor data from MPU9250 and applies certain control algorithms. In our case, it applies PID, that is proportional integral derivative, which we'll see in the later slides. So what it does is it basically gives us values to adjust the motor speeds. So our drone has 4 different arms with 4 different motors. And in case of some external factors like rain, vibration, or any other disturbance, the 4 different arms with 4 different motors require 4 different values to compensate for that disturbance. So this PID gives us those 4 different values. Along with this, the flight controller also side by side receive commands from the pilot or the autonomous system and translate them into motor signals to basically adjust the thrust roll ratio to maintain the desired maneuver, basically. Now coming to PID control system. PID control is a widely used feedback control technique that adjusts system inputs based on error signals. It basically consists of 3 control components: proportional, integral, and derivative. And we need to retrieve all these gain coefficients for our code to basically balance our drone in midair. And all these 3 components, gain coefficients, have their own importance. For example, the proportional gain amplifies the response to the error signal. The integral gain reduces steady state errors and improves system stability, whereas the derivative gain provides damping to the system response and helps reduce overshooting and oscillations. PID tuning is an iterative process that involves adjusting one parameter at a time while observing the system's response. So we need to be careful. Once we retrieve all the 3 gain coefficients, we can use them in our code to fly our drone without any crash. Also, 2 things that I didn't discuss in these slides is first, transmitter and receiver. For that, we can use FlySky i6 6-channel remote. The receiver terminals can be easily connected to the Arduino to control our drone using the remote. And second, later we can easily replace the receiver with Wi-Fi module to use a mobile app to control the drone. So that is all from my side on this project. Hope you have a nice day. Thank you.